Welcome back to the deep dive. We're here to take those huge, dense global reports and boil them down into the critical knowledge you need to really stay ahead.
And today, our mission is tackling probably the biggest economic topic out there right now, AI, specifically artificial intelligence and its imminent impact on global trade and the economy.
We've pulled together three really heavyweight sources for this deep dive. The main anchor is the big one from the World Trade Organization, their World Trade Report 2025, Making Trade and AI Work Together to the Benefit of All. A massive piece of work.
It is. It gives us that crucial macro view. But we didn't want to stop there.
Exactly.
Okay.
So we're balancing that global perspective by drilling down, into the micro stuff. We're bringing in key insights on labor markets, on corporate value from Morgan Stanley Research and the Penn Wharton budget model.
Which is so important because you get the big picture from the WTO, but then you see how it actually plays out or could play out for jobs, for companies, for stock prices.
Right. And pulling these together really highlights the core tension, doesn't it?
Absolutely. On one hand, you have this promise of just monumental global prosperity, AI boosting efficiency, creating new markets.
Yeah.
It's huge.
But there's always a but.
Yes. Every single one of these sources, they all warn, quite strongly actually, that unless we see serious targeted policy action, and soon, well, AI can just make existing inequalities, both global and domestic, much, much worse.
So the benefits get trapped, concentrated in just a few places.
Precisely. Trapped in a few already wealthy regions, leaving others further behind.
So it sounds like we're not just talking about a tech revolution. It's almost a policy challenge disguised as a tech revolution.
That's a great way to put it. We have to understand the mechanics of the growth, yes. How services are changing, how labor markets are shifting.
But we also really need to understand why policy is the bottleneck, why it's the crucial factor that decides whether this is shared prosperity or something else.
Exactly. And maybe the best way to grasp why policy is so urgent is to first understand the sheer scale of what's potentially at stake.
Yeah.
The prize, if you will.
Okay. Let's set the stage then. Give us the headline numbers, the big projections that make everyone sit up and pay attention.
All right. The WTO's primary projection, it's honestly breathtaking. They model that AI could boost the value of global trade, that's goods and services, by nearly 40%.
40%? Wow. By when?
By 2040. Their specific range is between 34% and 37% additional growth compared to a baseline without widespread AI adoption.
Okay, 40% on top of global trade, which is already, what, tens of trillions of dollars. That's transformative, doesn't even quite cover it.
It's a staggering acceleration. And it doesn't stop at trade. The WTO connects this trade boom directly to broader economic growth.
Right, the GDP impact.
Yes. They project that global GDP could rise by 12% to 13% by 2040, again, across their different AI uptake scenarios compared to the baseline.
12 to 13% global GDP growth. That's not just tweaking the dials. That's a fundamental shift in the entire global economy's trajectory.
It absolutely is. We're talking about a step change.
Okay. So nearly 40% jump in trade, 13% boost to global GDP within about 15 years, all driven by AI. I mean, have we ever seen projections like this tied to a single technology before? Maybe the internet itself, but this feels incredibly concentrated.
It's certainly among the most dramatic projections tied to a specific technological wave, yes.
So how? Let's unpack this. How does AI actually deliver that kind of economic shockwave? What are the mechanisms?
Well, the number one engine, the most powerful driver, according to the WTO analysis, is the digital services sector.
Right. We often think of trade as, ships and containers full of physical stuff, cars, electronics.
Exactly. But the WTO is crystal clear. Digital services are where the most transformative, most immediate impact is happening.
And the growth numbers for just that sector are even bigger than the overall trade figure, aren't they?
They are, disproportionately so. The WTO model calculates that trade in digitally deliverable services could see additional growth of almost 42% by 2040.
42%. Okay, why? What makes digital services so supercharged by AI? The WTO broke it down, right, into a few key factors.
Yes, they highlighted four main interconnected reasons. It's not just about making existing digital stuff faster, it's more fundamental.
Okay, lay them out for us. Because this is where we see AI isn't just a tool, it's becoming a tradable commodity itself.
Right. So factor one is perhaps the most obvious. AI significantly cuts operational trade costs within the service sector.
How so?
Think about automating compliance checks for cross-border services, handling complex logistics, planning for digital projects, managing customer service instantly in multiple languages. AI just removes a massive amount of friction.
Okay, makes sense. Lower friction, more trade. What's number two?
Number two is the projected growth of AI services themselves. We're talking
Yeah.
about AI as a service, bespoke machine learning models, sophisticated data analytics
Like
platforms.
these are new things to trade.
Exactly. High value, purely digital services. And because they're digital, they have incredibly high tradability. You can export them instantly across any border with a fiber optic cable. No shipping required.
And that high tradability links to the third factor you mentioned earlier, the geographic concentration.
It does, directly. Right now, the cutting edge of AI service development is heavily concentrated. Silicon Valley, parts of China, specific tech hubs in Europe.
So a few places are making this really valuable digital stuff.
And they can sell it globally, instantly, because it's digital. This geographic concentration of production, combined with high tradability, acts as a massive accelerator for global service commerce. It bypasses the physical constraints you see with manufacturing hubs.
Okay, so AI improves existing digital trade by cutting costs, and it creates a whole new class of high-value, easily traded digital exports coming from just a few places. What's the final piece? Factor 4.
Factor 4 is the above-average productivity growth within these AI-intensive sectors. Because they're built on exponential improvements in computing power, their output per unit of input, their particle, total factor productivity grows much faster than in traditional industries.
So they get more efficient faster.
Right, which tends to drive down the relative price of these advanced services globally, while simultaneously increasing the sheer volume being traded. More capability, lower cost, more trade.
Okay, so digital services are the clear engine here. But AI isn't purely digital, is it? It runs on hardware, massive amounts of it. That brings us to the physical side, the AI-enabling goods.
Absolutely critical. You can't have the AI service revolution without the physical backbone. We're talking semiconductors, especially those advanced GPUs. Everyone's fighting over specialized memory, cooling systems, servers, and all the raw materials needed to build them.
And trade in these goods is already huge.
Enormous. The WTO pointed out that trade in just these critical AI-enabling components hit $2.3 trillion globally in 2023.
2.3 trillion. That's important because it shows this isn't some future trend. This hardware is already a massive part of global supply chains today. It's shaping trade flows and, frankly, geopolitics right now.
Exactly. This physical infrastructure is the absolute prerequisite for the digital services boom we just discussed. If countries can't get affordable, reliable access to these goods, they simply cannot participate fully in the AI-driven service economy.
So beyond creating new things to trade, AI is also fundamentally about making the existing system, the nuts and bolts of trade, way more efficient. How is it lowering that trade friction, the costs, the delays, the complexity? What are companies actually doing with AI right now, according to the WTO?
They're using AI tools across almost every aspect of logistics and compliance. It's quite widespread already.
Like what specifically?
Okay, for supply chains, AI provides much better visibility. Companies can predict potential bottlenecks, optimize inventory, reduce the risk of stockouts or overstocking. That's a big one.
And customs, that's always a headache.
Huge improvements there. AI is automating customs clearance processing, digital paperwork, checking compliance databases, flagging suspicious shipments far faster and often more accurately than humans can. This really cuts down those bureaucratic delays that can kill sensitive supply chains.
Yeah, I can imagine for a small business trying to export, navigating customs is just a nightmare. AI could level the playing field there.
That's the idea. And it tackles another persistent, subtle barrier: language. AI isn't just doing basic translation anymore. It's providing real-time, context-aware communication tools.
So teams in different countries can collaborate better.
Much better. It helps with contract negotiation, ensuring everyone's on the same page, and generally improves the timeliness and reliability of information flow, which affects shipment accuracy.
So for those smaller companies, the MSMEs, the micro, small, and medium-sized enterprises that often lack the resources to handle complex international regulations, AI sounds like it could be a game changer.
Potentially, yes, a great equalizer. These AI tools can help them navigate that incredibly dense web of global regulations, thousands of different rules.
And access market intelligence too, right? Which used to be just for the big players.
Exactly. Giving them sophisticated data on consumer trends in foreign markets, competitive pricing, the best distribution channels, information that was previously only affordable for large multinational corporations. It really could democratize access to global markets.
Is this actually happening, though? Do we have data on whether firms are really seeing these benefits, or is it still mostly theoretical?
No, it's tangible.
Yeah.
The WTO research found that nearly 90% of firms that are currently using AI report seeing real benefits in their trade-related activities.
90%. That's a very high success rate for implementing a new technology.
It is. It suggests the tools are delivering value pretty quickly. And it's not just efficiency, it's risk management too.
Ah, right. How so?
A significant chunk, 56% of firms using AI, reported that it enhanced their ability to manage trade risks. That could be anything from compliance risks, spotting potential supply chain disruptions earlier, or even managing foreign exchange volatility better.
So the gains are real, they're measurable, and they impact both the bottom line through efficiency and the top line through better risk control.
Precisely. These aren't just abstract economic models. They translate into stronger, more resilient companies.
Okay, this is the perfect transition. We've seen the macro picture, huge trade and GDP growth. Now let's bring it down to the micro level, to those companies. When Wall Street or investors look at AI, they're seeing dollar signs. Let's talk about the Morgan Stanley analysis, the potential financial windfall for corporations, specifically looking at the S&P 500.
Right. Morgan Stanley took a different lens, focusing purely on the potential value creation within large corporations. And their numbers are, frankly, just as staggering as the WTO's trade figures.
Give us the headline benefit.
They estimate that if AI were fully adopted across the S&P 500 companies, it could generate an annual net benefit of up to $920 billion.
$920 billion annually.
Annually. And that's a net figure, accounting for both significant cost reductions and the creation of new revenue streams enabled by AI.
Almost $1 trillion a year just for the S&P 500. What does that mean for overall market value for investors?
Well, over the long term, that kind of annual benefit stream gets capitalized into market value. Morgan Stanley projects this could lead to a long-term increase in the S&P 500's market capitalization of somewhere between $13 trillion and $16 trillion.
13 to $16 trillion.
Yes, which represents a potential increase of roughly 24% to 29% from current market levels. Again, all predicated on successful, widespread AI adoption realizing these gains.
We need to break down that $920 billion annual figure, though. Because it's not just one type of AI driving it, right?
Yeah.
Morgan Stanley distinguished between the AI brain and the AI body.
That's a crucial distinction they made. They split the benefit roughly in half. About $490 billion of that annual $920 billion is attributed to what they call agentic AI.
The software brain.
Exactly. The sophisticated software that can plan, make complex decisions, execute tasks with minimal human oversight. Think advanced customer service bots, predictive maintenance algorithms, automated code generation.
Okay, so that's nearly $500 billion from the software side. What about the other half?
The remaining $430 billion is projected to come from embodied AI.
The robots.
Essentially, yes. Physical systems that interact with the real world. Humanoid robots in warehouses or manufacturing, advanced industrial automation, autonomous delivery vehicles and logistics. It's the combination of the smart agentic AI optimizing things and the physical embodied AI carrying out the tasks that generates that near $1 trillion annual boost.
Interesting. So agentic AI tackles the white-collar optimization. Embodied AI handles the physical world optimization. Makes sense. Now, we know the technology itself, the AI capability, is improving incredibly fast, doubling every 7 months, you said.
Roughly, yes, based on the compute used for training state-of-the-art models over the last 6 years or so. It's exponential.
But the economic impact isn't instant. It doesn't just flip a switch. The Penn Wharton budget model looked closely at this, at the timing of when these productivity gains actually filter through the economy. What did they find?
Right. Technology adoption always takes time. There's a lag. Firms have to invest. Workers have to adapt. Processes have to change.
We saw this with PCs, with the internet, with smartphones.
Exactly. History shows these S-curves of adoption. There's initial hype, then investment, then a period of slower uptake, and finally, widespread integration. Though it's worth noting that generative AI, kicked off publicly by ChatGPT in late 2022, seems to be getting adopted somewhat faster than previous waves.
Is there data on that initial uptake?
Yes, the Penn Wharton data showed that by the second half of 2024, about 26.4% of workers reported using generative AI tools at work. That's a pretty rapid initial penetration compared to historical precedents.
Okay, but rapid initial use isn't the same as economy-wide productivity gains. The real impact comes when it boosts total factor productivity, TFP. Can you just quickly remind us what TFP measures?
Sure. TFP, total factor productivity, is basically the secret sauce of economic growth.
Hmm.
It's the part of output growth you can't explain just by adding more workers or more machines. It represents technological progress, innovation, efficiency gains, getting more output from the same inputs. When TFP goes up, the whole economy gets fundamentally better at producing things.
Got it. So when does Penn Wharton expect this AI adoption to translate into significant, broad TFP gains that really move the needle on GDP? Is it happening now?
Not quite yet, according to their projections. They see the peak impact on the rate of TSP growth happening around the early 2030s. Specifically, they pinpoint roughly 2032.
So still almost a decade away for the peak boost to growth.
For the peak annual contribution, yes. Around 2032, they project AI will add about zero point 0.2 percentage points to the annual TFP growth rate, which is significant for TFP growth. But after that peak, the contribution to the growth rate starts to diminish as the technology becomes more saturated.
But crucially, the level of economic activity doesn't drop back down, right? The gains become embedded.
Exactly. That's the key distinction. AI creates a permanent uplift in the level of economic potential. PWBM projects the overall GDP level will be 1.5% higher by 2035 than it would have been without AI. And that effect persists and grows, reaching 3.7% higher by 2075.
So it permanently raises the ceiling of the economy, like raising the water level, as you said.
Precisely. It's a permanent increase in the economy's overall productive capacity.
And they also found a small lingering effect on the growth rate itself, even after AI adoption is complete, like even after 2075. Why is that?
Yeah, a very small but permanent boost to the long-run growth rate, less than 0.04 percentage points. It comes down to a structural shift in the economy.
How so?
The sectors that are most exposed to AI and benefit most from it, think software, professional services, IT. These also happen to be sectors that already had faster underlying TFP growth trends before AI really took off.
Ah, okay. So AI makes these fast-growing sectors even more important in the economy.
Exactly. They grow faster, they become a larger share of the total economy, and because a larger slice of the economic pie consists of these inherently faster-growing sectors, the overall average growth rate of the entire economy gets a tiny permanent lift.
Fascinating. Okay, so this talk of efficiency, automation, productivity gains, it leads us straight into the labor market. This is where the rubber meets the road for most people and where there's, frankly, a lot of anxiety. Morgan Stanley said 90% of occupations affected. That's huge. Job killer or job creator. What's the consensus?
Well, affected doesn't necessarily mean eliminated. The historical pattern with major technologies is usually net positive job creation in the long run. But, and this is a huge but, the types of jobs change dramatically.
It's a massive disruption and need for retraining.
Unprecedented need for retraining and reskilling. We're talking about a generational challenge to adapt the workforce to work with AI, not be replaced by it.
And that agentic versus embodied AI distinction matters here too, right? In terms of who gets disrupted how.
Very much so. Agentic AI, the smart software, affects a wider range of occupations, particularly white-collar, knowledge-based roles. But often, its initial effect is augmentation. It takes over routine cognitive tasks, freeing up humans for higher value analysis, creativity, strategy.
But the embodied AI, the robots, that's different.
That carries a higher risk of direct displacement for certain roles. Embodied AI impacts fewer occupations overall. But for those specific jobs, often physical or manual tasks in logistics, manufacturing, maybe even some services, the likelihood of automation replacing the human worker is higher.
And the Penn Wharton data suggests we're already seeing the beginnings of this displacement in the most vulnerable jobs.
Yes. The data since 2021 is suggestive. Occupations identified as having the highest potential for AI automation have seen stagnating or falling employment. Particularly for the small group of jobs deemed almost fully automatable, employment actually dropped noticeably in early 2024, falling below its 2021 peak.
The writing's on the wall for the most exposed roles.
It appears so. The initial impact is hitting where you'd expect.
Okay, now this brings us to what might be the most surprising finding from Penn Wharton, something that really turns conventional wisdom on its head. The profile of who is most exposed based on earnings. We tend to think robots replace the lowest paid workers first.
The classic image of the factory robot replacing the assembly line worker.
But the data shows something else entirely, almost a paradox.
It does. It's quite striking. The highest level of task exposure to AI automation isn't found in the lowest paying jobs. It's concentrated around the 80th percentile of earnings.
Wait, the 80th percentile, so not the minimum wage workers, not the CEOs, but the high-earning professionals in the upper middle, like programmers, engineers, analysts.
Exactly those kinds of roles. People with degrees, specialized skills, often high digital literacy. They are, according to the task analysis, the most exposed group.
Why? That seems completely counterintuitive. Why is the skilled digital worker the most vulnerable?
It boils down to the types of tasks AI excels at right now. Current AI, especially generative AI, is incredibly good at automating intermediate, often repetitive cognitive tasks.
Tasks that involve processing information in predictable ways.
Precisely. Think about a mid-level software engineer generating boilerplate code, or a financial analyst compiling data for a standard market report, or maybe a paralegal sifting through documents for discovery. These are well-paid jobs requiring skill, but the core tasks often involve processing information in structured, data-intensive, somewhat predictable ways.
And AI is getting very good at that specific kind of cognitive work.
Extremely good. The analysis suggests that, on average, about half of the tasks performed in these 80th percentile occupations could potentially be automated by current or near-future AI.
So where is the least exposure then?
At the two extremes, the lowest-earning occupations often involve manual dexterity, physical interaction with the world, or complex person-to-person service things AI still struggles with. Think construction, food service, elder care.
And the very top earners.
Also low exposure. Top executives making strategic decisions, leading specialists performing complex surgery, elite athletes. Their value comes from highly complex, often novel, non-replicable judgment, creativity, or unique physical abilities that AI can't yet mimic.
Wow, so the squeeze is really on the skilled white-collar middle. That's going to have major implications for wages, surely. What did the WTO report model regarding the skill premium, that historical gap between high-skilled and low-skilled pay?
This is another counterintuitive finding. Based on their modeling of task substitution, the WTO projects that the global skill premium, the ratio of high-skilled to low-skilled wages, might actually decline slightly.
Decline. Doesn't AI require more high-skilled workers? People who can build and manage the AI?
It does create demand for some very high-end AI specialists, yes. But the modeling suggests that, on balance, the substitution effect is stronger for many existing medium and high-skilled roles than it is for low-skilled roles.
Because AI is better at automating those intermediate cognitive tasks we just discussed.
Exactly. AI is replacing, or significantly augmenting, tasks currently done by moderately and highly skilled workers more effectively than it's replacing tasks done by low-skilled workers requiring manual dexterity or direct human interaction. Think about it. AI can draft a legal brief faster than it can reliably fold laundry or provide empathetic nursing care.
So, paradoxically, by automating parts of high-skilled jobs, AI makes that type of labor relatively less scarce compared to low-skilled labor that's harder to automate.
That's the logic behind the projected slight decline in the premium, yes.
Yep.
A relative decrease in demand for those intermediate to high skill sets compared to the persistent demand for many low-skilled tasks.
And this is crucial, overall wages are still expected to rise for everyone, right? Because the whole economy is becoming more productive.
Absolutely. That's the critical positive takeaway. Despite the potential narrowing of the skill premium, the overall TFP boost from AI means the economic pie grows significantly. Real wages are projected to rise for all labor groups low, medium, and high-skilled. Everyone should be better off in absolute terms, even if the relative gaps shift slightly.
Okay, that makes sense. To make all this more concrete, the value creation, the automation, let's look at a few specific industry examples Morgan Stanley highlighted. Where will we actually see this AI value being generated?
They gave several good examples. Let's take three. First, consumer staples, distribution, and retail.
Okay, supermarkets, everyday goods.
Right. Here, AI delivers on two fronts. Cost savings through agentic AI, optimizing notoriously complex supply chains in real time, predicting demand, managing inventory, routing deliveries much more efficiently.
And the revenue side.
Even bigger potential there. Hyper-personalized pricing based on individual customer data, intelligent product recommendations, and search functions that drastically improve online conversion rates, basically making selling more efficient and targeted.
Okay, logistics efficiency and hyper-personalized sales. What was the second example?
Real estate management and development. This one is interesting because so much of it involves routine cognitive work and paperwork, scheduling, basic client interaction.
And Morgan Stanley put a number on the automation potential.
They estimated that around 37% of tasks in this sector are susceptible to automation. That's largely agentic AI, I think virtual assistants managing client inquiries, AI optimizing building maintenance schedules, generating standard lease agreements or financial reports.
Any embodied AI there?
Some potential, yes. They mentioned things like humanoid robots being explored for tasks like automated property inspections or maybe even basic sales assistants in large developments.
Okay. And the third example, transportation, which is obviously core to global trade.
Yes, transportation and logistics. This sector is poised for a complete redefinition, largely driven by autonomy. Morgan Stanley specifically highlighted the rise of autonomous delivery systems.
Drones and sidewalk robots.
It's exactly. Moving from pilot projects to potentially large-scale deployments for last-mile delivery, this kind of autonomy could fundamentally change logistics costs and speed, feeding directly back into those WTO trade friction reduction numbers.
Right. Lower costs, faster delivery times, globally.
That's the vision.
Okay. So we've painted this picture. Potentially $16 trillion in new market value, a 40% boost to trade, rising real wages. But it all sounds incredibly dependent on this technology actually spreading everywhere fairly. And this is where we hit that major warning sign you mentioned earlier.
This is absolutely the crux of the policy challenge highlighted by the WTO. Their central caution, repeated throughout the report, is that AI's potential benefits are massive, but realizing them equitably is not guaranteed. In fact, without deliberate intervention, AI is more likely to deepen inequalities.
Why? Because the capability is so concentrated right now.
Precisely. The resources needed to develop and deploy cutting-edge AI. We're talking about the digital infrastructure, the advanced hardware, the highly skilled workforce, are overwhelmingly concentrated in just a handful of high-income countries.
Is there hard data on that concentration, like investment flows?
Yes. The WTO points to statistics on government subsidies for AI-related products and research. Over 98% of these global subsidies are happening in high-income and upper-middle-income economies.
98%? Wow.
It shows a massive focus of public money and effort that's essentially locking in the technological advantage for the developed world.
And this concentration must be showing up in adoption rates too, right? Especially for smaller firms or poorer countries.
Absolutely. The digital divide is stark. The WTO cited survey data showing only about 41% of small firms globally are using AI, compared to over 60% of large firms. Big companies can afford the talent, the data infrastructure, the investment.
And geographic.
Even worse, adoption rates plummet in the developing world. Fewer than one-third of firms in low-income and lower-middle-income economies, the WTO calls them LICEs, are currently using AI.
So if you can't access the tools, you can't get the productivity gains, you can't participate in the trade boom.
You get left behind. It becomes a self-reinforcing cycle, deepening the global divide.
This is why those WTO catch-up scenarios are so critical. They actually model the difference policy could make for these low-income economies.
Yes, this comparison is probably the single most important policy message in the entire report. They look at what happens to real income growth in LICEs by 2040 under different policy assumptions. Let's call them the deepening gap scenario versus the catch-up leap scenario.
Okay, start with the bad news. What happens in the deepening gap scenario where things basically continue as they are?
All right, scenario one, no catch-up, assumes LICEs don't significantly close their digital infrastructure gap compared to richer countries. They maintain the status quo on policy. In this case, their real income is projected to grow by a modest 8% by 2040.
8% growth over 15 years? Okay, it's positive, but not exactly transformative.
Right. And here's the kicker. In that same scenario, high-income economies see their incomes grow by 14%.
Ah, so the gap widens significantly. The rich get richer faster.
Exactly. The benefits of AI disproportionately flow to the already wealthy nations, structurally embedding greater global inequality.
Okay, that's the grim scenario. What about the alternative? The catch-up leap. What if LICEs do make a serious effort?
Now, scenario two, partial catch-up, assumes LICEs make significant policy changes. They manage to close their digital infrastructure gap by 50%, meaning major investments in broadband, affordable devices, digital skills, and they encourage widespread AI adoption domestically.
What happens to their income growth then?
It skyrockets. Projected real income growth for LICEs reaches 15% by 2040.
15%. That's nearly double the growth compared to the do-nothing scenario.
Almost double the game. It fundamentally changes their economic trajectory.
And what happens to the high-income countries in this scenario? Does the developing world's gain come at their expense?
Not at all. That's the beauty of it. In the catch-up scenario, high-income economies still see strong growth. 12% real income growth by 2040.
So slightly less than the 14% in the other scenario, but still very strong.
Exactly. The key difference is that the global economic pie grows much larger, and the gap between rich and poor nations starts to narrow because the LICEs are catching up, growing faster. It demonstrates that proactive policies supporting AI diffusion are a win-win globally. Better growth, better equity.
But even as reports like this call for spreading the technology, the WTO itself pointed out that policy barriers are actually going up, especially from richer countries.
Yes, that's a major contradiction and source of tension. Trade barriers, specifically targeting AI services or the crucial enabling goods like advanced chips, are increasing.
How much?
The number of quantitative restrictions quotas, licensing requirements applied to AI-related goods, jumped from about 130 back in 2012 to nearly 500 in 2024.
Wow. And these are mostly imposed by...
Largely by high-income nations, often citing national security concerns or the need to control strategic technologies. But the effect is to restrict the global flow of the very technology needed for that catch-up scenario.
And it's not just restrictions from rich countries, right? Developing countries sometimes have their own barriers, like high tariffs on imported tech.
That's the other side of the coin. Existing tariffs on imported AI-enabling goods, computers, servers, network gear can be very high in some LACEs, reaching up to 45% in certain cases.
So they make the essential hardware prohibitively expensive for their own businesses and people?
Exactly. It makes building the necessary digital infrastructure incredibly costly, further cementing that gap we talked about.
So you have restrictions on supply from rich countries and high tariffs blocking demand in poor countries. How do we break this logjam? What did the WTO recommend to actually make AI accessible globally?
Their main plea was for renewed commitment to multilateral cooperation through the WTO itself. Two key areas.
What's the first?
Broader participation in the WTO's Information Technology Agreement, the ITA.
Remind us quickly what the ITA does.
It's an agreement where signatory countries commit to eliminating tariffs, bringing them down to zero on a whole range of IT products, including computers, semiconductors, telecom equipment, basically the AI-enabling goods.
So if more countries, especially LICEs, joined or fully implemented the ITA,
you would immediately make the essential hardware cheaper and easier to import, tackling that tariff barrier head-on.
Okay, that's hardware. What about the services side?
They recommended updating commitments under the General Agreement on Trade in Services, or GATS.
GATS is the WTO agreement covering services trade. How does it need updating for AI?
The idea is for countries to make clear commitments under GATS that specifically cover modern digital and AI-driven services, things like cross-border data processing, cloud computing services, AI platform access. This would provide more regulatory certainty and prevent countries from putting up unnecessary barriers to trading these crucial new services.
So renewed multilateralism via the ITA for goods and updated GATS commitments for services. That's the path forward.
That's what the WTO argues is essential. International cooperation is key to ensuring AI benefits are shared and don't just exacerbate the divides.
Okay, let's try to synthesize this huge amount of information for you, the listener. The core message seems clear. AI is an incredibly powerful engine for global trade growth. Think almost 40% boost by 2040.
That growth is mainly driven by digital services, which benefit from reduced costs, high tradability, and rapid productivity gains. But it all rests on a foundation of physical enabling goods, like semiconductors.
We're looking at massive potential corporate value creation, maybe $16 trillion added to the S&P 500, with the peak productivity gains hitting the economy in the early 2030s.
The labor market impact is profound. It affects almost everyone, but the biggest automation pressure seems to be on the high-earning, skilled, middle, those 80th percentile jobs, doing complex but predictable cognitive work. Yet overall, real wages should still rise for everyone due to higher productivity.
And this is the giant flashing warning sign. None of these benefits are guaranteed to be shared. The technology and investment are hyper-concentrated right now.
And without strong policy action, international cooperation to lower barriers, like expanding the ITA and updating GATS, and domestic investment in infrastructure and skills, especially in developing nations, AI could very easily widen the gap between the rich and poor world. That deepening gap scenario is a very real possibility.
Before we wrap up, there was one more fascinating detail in the WTO report, a kind of psychological divide regarding AI.
Ah, yes, the optimism divide.
Yeah.
It was quite striking. They cited polling data showing vastly different attitudes. In developed regions like Europe, something like 70% of people fear losing their jobs to AI. A lot of anxiety.
70% fear displacement. But I contrast that with developing countries.
where two-thirds of people apparently think their lives will actually be better because of AI.
Yeah.
So fear in the developed world, hope in the developing world. A stark difference in perspective.
That optimism is a powerful potential asset for developing nations, isn't it?
It absolutely could be. Which leads us to our final provocative thought for you to consider.
Okay. Given everything we've discussed, especially that surprising finding that AI automation hits the high-skilled middle, the 80th percentile hardest, and given this global optimism gap,
What specific policies, beyond just building basic digital infrastructure, do developing nations need to put in place right now? They have this huge pool of optimistic citizens, often young populations. How can they harness that optimism?
how do they strategically design education, training, and economic policies to prepare their workforces not just to use AI, but to thrive in the new economy AI creates, to leapfrog the displacement anxiety gripping richer nations?
How do they ensure that hope translates into real opportunity and avoids replicating the challenges faced elsewhere? That's the multi-trillion-dollar question for policymakers in the developing world. Something to think about.